Right, so this question is asking you to solve the system of linear equations using Cramer's rule. Now, as always, we're going to start off with making our matrices. So for Cramer's rule, we have three different matrices. First one is going to be D. This one is all of our variables and not our answer, so just not an augmented matrix. Here we have 3, 0, 1, 0, 2, negative 1, 2, negative 1, 0. Now we're going to have dx. I'll change the color. Dx. This matrix, we're taking our x's and we're replacing them with our answers. So here I have 1, negative 1, 1. And now for the other two columns, it's the same thing. So 0, 2, minus 1, 1, negative 1, 0. Now for dy. For y, we're going to replace y with our answer. So x is just normal. It's 3, 0, 2. Y is going to be 1, negative 1, 1. And then z is 1, negative 1, 0. Last but not least, we have our dz. And in this case, it is our third column that is going to be replaced with our answers. So we have 3, 0, 2, 0, 2, negative 1, 1, negative 1, 1. All right, now we just need to solve for the determinants of every single one of these. I prefer using Saurus rule. We have a 3 by 3 matrix. So let's start out with D. I'm going to put the answers at the end, right up here, so we remember them. For D, we rewrite this. So we have 3, 0, 2, 0, 2, negative 1, 1, negative 1, 0. Now I'm just going to continue expanding it. So 3, 0, 2, 0, 2, negative 1. Now for our diagonals, we have this one, and this one. Then we have this way. Try not to block out our numbers completely. And let's rewrite these. So we have 3 times 2 times 0, which is 0. 0 times negative 1 times 2 is 0. 1 times 0 times negative 1 is 0. 2 times 2 times 1 is 4. Negative 1 times negative 1 is 1 times 3 is 3. 0 times 0 is 0. So here, 0 minus 4 plus 3 is 7. Is equal to negative 7. So we just found the determinant for D is negative 7. Alright, let's find the determinant for dx now. We have 1, negative 1, 1. 0, 2, negative 1. 1, negative 1, 0. And let's continue it. So 1, 0, negative 1, 2, 1, negative 1. And now we can draw our diagonal line. So we have change color. And so these here, these and these. Try not to be like me who crosses out the numbers themselves. Now we have 1 times 2 times 1 is 2. Negative 1 times negative 1 is 1 times 1 is 1. 0 is here, so 0. 1 times 2 is 0. If you see a 0, you know the answer is 0. 1 times negative 1 is 1. So we have 1 minus 2 plus 1 is 3. 1 minus 3 is equal to negative 2. Now I know that dx is equal to negative 2. Okay. For dy, we have 3, 1, 1, 3, 1, 0, negative 1, negative 1, 0, negative 1, 2, 1, 0, 2, 1. Gonna be a little bit careful this time. So here we have these three, and these three. We're just drawing the diagonal lines again. Okay. So 2 times negative 1, negative 2 times 1, still negative 2. 1 times negative 1 times 3 is negative 3. 0, so that's 0. 0 here. Negative 1 times 2 is negative 2, and 0. I have negative 2 minus minus 2 plus minus 3 is equal to minus 5. So minus 2 minus minus 5 is equal to 3. So I know that dy is equal to 3. Last but not least, I have dz, so 3, 0, 1, 3, 0, 0, 2, negative 1, 0, 2, 2, negative 1, and I'm not sure what that is, that's a 1, 2, negative 1, 1, 2, negative 1. Now we have these three numbers, and these three. My diagonal lines are not at all straight this time. So we have 3 times 2 times 1, which is 6, 0, and 0 here. We have 4 here, 2 times 2 is 4. Negative 1 times negative 1 is 1 times 3 is 3, and this is 0. 4 plus 3 is 7. This is 6. Oh, that was bad. 6 minus 7 is equal to negative 1. So dz is equal to negative 1. So x is equal to dx over d. Y is equal to dy over d. And z is equal to dz over z. Here we have, change colors again, dx, which is negative 2 over d, which is negative 7. Here dy is 3 over d, which is negative 7, and dz is negative 1 over negative 7. So up here, let's just write our answers. We figured out that x is equal to 2 out of 7, y is equal to negative 3 out of 7, and z is equal to 1/7.